Here's a wild thought. What if the universe didn't just begin with a simple bang, but with a fraction of a second of unimaginable expansion, stretching faster than the speed of light? This is what the theory of cosmic inflation suggests, and it's one of the most mind-bending ideas in modern physics. Let's break it down. After the Big Bang, the universe wasn't anything like what you're picturing today. Initially, it was extraordinarily dense, extremely hot, basically pure energy packed into a microscopic dot. But something peculiar seems to have happened within the first tiny fraction of a second. Think 1 × 10 to the power of -32 seconds. During this fleeting moment, the universe didn't just expand, it inflated. Picture a balloon that goes from pinprick size to larger than a galaxy in basically no time at all. Here's where inflation gets fascinating. It wasn't just a fast stretch, it was exponential. That means each moment, the universe grew at a rate that dwarfed the moment before. This inflation wasn't bound by the speed limit of light expansion because it wasn't things moving through space. It was space itself inflating. This subtle but critical distinction is allowed by Einstein's equations of general relativity. Now, why do we believe this happened? Observational clues lie in something called the cosmic microwave background, or CMB. It's faint radiation coming from every corner of space, basically the afterglow of the Big Bang. What's wild is how uniform it appears, like everywhere in the visible universe had time to sort itself out and cool down evenly. Without inflation, the early universe wouldn't have been able to communicate across such vast distances to achieve this balance. Inflation is the best explanation we have for why the cosmos looks the way it does, smooth and homogeneous, but peppered with tiny fluctuations that later evolved into galaxies. But inflation isn't a unanimous theory. Some physicists have pointed out gaps. For instance, what kick-started inflation, and what caused it to stop? There's also the idea that inflation might suggest our universe is just one bubble in a vast multiverse, each bubble with its own rules of physics. Whether that's evidence for something deeper or a leap into pure speculation, that's still up for debate. If you're hungry for more short or in-depth dives into advanced physics, tech, and philosophy, subscribe to Hyperfocus. I'll see you there.